Hi, today I'm presenting the poster entitled Individual Items in Visual Working Memory Inherit Ensemble Properties. When we run experiments with visual working memory, we usually manipulate memory load in terms of separate items, like whole objects or their features. In the result, we estimate some important parameters such as the probability of recall and representational precision. In doing so, we often assume that items are encoded, stored, or forgotten as separate units, independent from other items. However, we know that individual items are probably not that independent. For example, we can recall individual features shifted to the average feature of all remembered items. That is, we say that individual memories are biased by the ensemble information. So today, I'm going to tell about new evidence that critical parameters of visual working memory representations, in particular precision, which is so important for many working memory models, in fact, inherit quite a lot from ensembles. In our main experiment, we had participants perform 3 visual working memory tasks in separate blocks. They had to remember 1 orientation, 4 orientations, or the average ensemble orientation of 4 triangles. In a trial, they were first shown a pre-cue for 1 pointing to the particular location, all 4, or the average. Blank, then a sample with 4 triangles, 1 second of retention, and a continuous report screen, individual or the average. Feedback of response correctness at the end. We had 3 ranges of orientations, 30, 60, and 120 degrees, which provided the goodness of ensemble organization by similarity. Results. We analyzed the error distributions in the orientation space, and this is our data for all tasks and ranges. 0 means correct answer. Note that for individual items, that is 1 and 4 tasks, we plot the error such that a positive direction is always toward ensemble mean and negative is always away from that mean. So, in remember 1 task, the error was always predictably small and centered at 0. But in the other 2 tasks, the distributions clearly become wider as the stimulus range increases. Moreover, you can see that the set size 4 distributions are positively biased or biased toward mean. The same pattern is in the mean plots. First, the circular deviation of errors, which is inverse precision, grows as function of range in the ensemble task, and so does it in set size 4. And we also see that responses are biased toward mean in this set size 4 task. So we see strong resemblance between what people do in the ensemble task and the remember 4 task. But if there is such a resemblance, is it possible that observers just give up and report the average instead of more demanding 4 items? To answer this question, we simulated what remember 4 distributions would look like if observers just averaged. The simulations are informed by the distributions observed in the averaging task. We see that the simulated distributions, dotted lines, are progressively more biased than the data. And in fact, in the smallest range, they're almost the same, but they're substantially more different in the larger ranges. So although the absolute bias grows with range, it decreases as a proportion of the distance between the correct answer and mean. That is, when range grows, individual responses are relatively less attracted by the mean. So far, we tested the influence of ensemble on memory for orientations that are intentionally organized in ensemble by range control. But when researchers study item memory, they usually generate the items randomly and thus more independently. So would the ensemble effect be preserved in this case? We tested it in a new study on mTurk. We pre-generated 48 displays of 3 randomly oriented triangles and showed them to almost 300 workers, so each display yielded a reliable error distribution. Our 48 displays covered a very broad variety of ranges, and you may see examples of this variety. And again, we find a pretty high correlation between the range of these randomly generated orientations and the error. And we also see the overall positive bias that is toward mean, and that this bias decreases in a proportion to the distance between correct answer and mean as range increases. To remind, we observed the same in the main experiment. So it seems like observers tend to more rely on reporting just the average when the range is smaller and so the items are more similar, which makes sense. To conclude, we see that recall precision of individual items strongly correlates with the precision of ensemble representation in working memory, and that individual reports are biased toward ensemble. And the more similar the items in an ensemble, the more they're biased. These findings are consistent with the hierarchical encoding framework, suggesting that information in working memory is stored and retrieved at different levels of abstraction. That's basically it. And if you want more detail on this study, please see our paper just out in JPHPP. And also check Jonathan Keefe's poster at vVSS for an important follow-up using EEG. Thank you.